Question 9 says, the graph of g of x, which is a cubic function, is sketched below. The graph of g intersects the x-axis at -5 and 0 and at p, and the y-axis at 0 and 20. P and R are turning points of g. Show that b is equals to 1, c to -16, and d is equals to 20. So we have to show basically get the equation of this cubic function, which currently has three unknowns. We know that a is equal to 1 ax cubed plus bx squared plus cx plus d. So what we can do first is say take this point that we have been given, which is a intercepting point, and substitute it into our graph. But since we can clearly see that at P we have two intercepts and the other intercept is at -5, we can rewrite this function into the form g of x is equals to a x minus let's say x minus x1, x minus x2, and x minus x3, where x1, x2, and x3 are the three intercepts of our axes. But in this case, x2 and x3, so we have x1 here, but x2 and x3 are on the same position because at that point there's a turning point and it touches, you can think about it touching it twice. But basically, since a is 1, we can rewrite our equation. I'll use y instead of g of x. Put 1 over there, you don't really need to. Then there will be x minus -5, which will be +5, like that. And then the other one will be x minus x, we just say x2, since x2 is equals to x3. And you can say squared, since there's two of them. There's x minus 2 and x minus 2 here. Together they form the square. Then we can substitute in a point. So on our graph here, we can substitute this point in, which is 20, or in coordinate form 0 is to 20, like that. So putting in 20 for our y and 0 for our x, 0 plus 5, which will just be 5. And here we have our x again, we put 0, so we just have minus x2 squared. And then we divide both sides by 5. That gives us, and take x squared to the other side, that will be x squared is equal to 4, like that. And then we square root both sides to get x is equals to plus minus 4. But which one makes more sense? No, not x plus minus 4, but x plus minus 2. So we have to look at which one makes more sense. We can't have p being on this side because clearly p is on the right hand side of our y-axis, so it's going to be positive. So x will be equal to 2 and only positive 2. Once we have that value, we can substitute it all back in. So this was x2. Let me be consistent in my naming of this variable. That means x3 is also equal to 2, but we don't really need it since we've simplified it up to this point. So we have y is equals to a is 1, so it's just x plus 5, x minus 2, and then squared. And then now we can expand on this entire thing. So we can keep the x plus 5 here and then expand on this. This will be x squared. X times -2 will be minus 2x times 2. That will be minus 4x. Minus 2 squared, that is plus 4. Like that. Then y is equal to, we multiply inside both by x and by 5. If you do that, you get x cubed minus 4x squared plus 4x. This is with the x. then multiply the 5 by everything as well. You get plus 5x squared minus 20x plus 20, and then we can join the like terms. So x cubed is on its own, and then minus 4x plus 5x, that's x squared. So our final equation will look something like this: x cubed plus x squared minus 16x, that's coming from minus 20x plus 4x, and then we have 20 plus 20. So here we can see our values. If we rewrite it in its standard form, we will have y is equals to a x cubed plus b x squared plus c x plus d. And here we can see that b is equal to 1, c is equals to minus 16, and d is equals to 20. And therefore you have shown a has been 1, and we haven't needed to calculate that one at least. So this is your proof, and that is your answer.